Thanks for meeting me here, Ned. I really needed a friend to talk to.
Sure, Sandy. You know that I'm here for you anytime. What's wrong? Are you still having problems with Luke?
I don't know what to do. Looks like he has left me for good this time. I woke up this morning and all of his stuff was gone.
Really? He took everything? Even the electrons?
Yes. Even those. I'm so upset. What am I going to do? Now I'm just a secondary carbocation all alone in this big world.
Come on, Sandy. Don't say that. You have so many opportunities for hydride or methyl shifts.
You're right, Ned. I've got to change my outlook on the situation. No more crying over Luke.
That's the spirit.
I am in control of my destiny. The rate law depends on me and me alone. I'm a material girl and this is my unimolecular world.
You're absolutely right. You know, Sandy, now that Luke is gone, I have a slight confession.
Yes, Ned.
I never really liked Luke and never understood what you saw in him. I always thought that you were way too good for him.
Really? Thanks, Ned, that's very sweet of you.
I could never put my finger on it, but there was just something about him that rubbed me the wrong way. I've never been a big fan of hydroxides.
Yeah, he had changed a lot over the course of our relationship. He was great when we first started dating, except for his low self-esteem, but I blame his parents for that. He came from a family of good leaving groups, but he was never able to meet their high expectations. His parents were so ashamed of him and always compared him to his older brother. I loved and bonded with him regardless of his imperfections. I still remember the day I met him. I thought my Prince Charming had arrived. Until
what?
Until they hired a new dental assistant at his office. Her name was Helen Hydronium. I met her one day when I dropped by Luke's office during lunch. She was very polite and friendly with me. But I could tell by the way she was looking at and flirting with Luke that she was up to proton 8, my man. From that day onwards, I became extremely suspicious of his late nights working at the dental office. Then, last week, I found an extra proton in the glove compartment of his convertible and reeked of cheap woman's perfume.
You must have been devastated.
I was. And after that day, I had this unshakable fear that he would leave me. Just like that. And he did, without even saying goodbye.
Come on, Sandy. Cheer up. You're a beautiful, intelligent, caring, electrophile. You don't need a jerky leaving group like him. You deserve much better. He's a loser.
Well, I suppose you're right. I see that, now.
You've got to brush yourself off and get out there again. Have you ever thought about bonding with a nucleophile?
Well, yeah, I mean, I have thought about it. But they seem like they're out of my league. What would an electron-rich nucleophile want with me and my empty orbitals?
Are you kidding me? You're beautiful. You've got a great sense of style and an extremely positive charge.
This morning, shortly after Luke had left, I was browsing on a product solvent personals, but all of those nucleophiles seemed to be looking for primary carbocations, and were very particular about being a part of the rate law.
Seems like you were looking in the wrong place. And just between us, you've got way more to offer than a primary carbocation. You're much more stable and definitely more reactive. Oh wow. I can't believe it's already 10:30. I'm so sorry to cut this evening short, but I've got to get back to the lab. I'm working on my doctoral dissertation on SN1 reactions.
I completely understand. Please don't apologize. I've always found organic chemistry to be very intriguing, and I would hate to keep you from your research any longer than I already have.
Organic chemistry is indeed very intriguing. Orbital overlapping, functional groups, Lewis acids, pi bonds, stereochemistry, resonance structures. Don't get me started on those. If I start talking about those, we will surely be here until next week.
Tell me a little bit about your research.
Well, I've been researching some general characteristics of SN1 reactions. So far I've observed that tertiary substrates react most quickly, secondary substrates react less quickly, and can react by either SN1 or another process called SN2. Primary substrates tend to react by SN2 as well. I've also noticed that the rate of the SN1 reaction is dependent on the substrate only, and that carbocation rearrangements are possible, as well as proton transfers which can occur at the beginning and end of the reaction. Last week I discovered that SN2 reactions prefer strong nucleophiles, whereas SN1 reactions prefer weak nucleophiles, since the rate law is not dependent on the nucleophile. Right now I am trying to test my hypothesis that polar product solvents, such as water, methanol, ethanol, acetic acid and ammonia, favor SN1 reactions. I'm not boring you, am I?
Not at all. I find this all very interesting. You know what?
What?
I'm wondering why an intelligent, handsome, ambitious guy like yourself is still single. I bet you have to fight the ladies off with a stick.
Well, I do spend quite a bit of my free time in the laboratory, so that limits my level of social interaction. And to be quite honest with you, I'm saving my electrons for just the right substrate. I hope I'm not being too forward, but would you be interested in a nucleophilic attack sometime? I find myself undeniably attracted to you.
Yes, a nucleophilic attack sounds lovely. I think there is a 50-50 chance that you could bond from either direction. Our mixture will surely include inversion as well as retention of configuration, or as some people say, it will be racemic 1, if you catch my drift. Wink wink.
Great. Why don't we head back to my place, light the Bunsen burner and pop open a flask of polar product bubbly?
Sounds great, let's go.